Hello class, today we are going to talk about exponential and logarithmic inequalities. And really, once you've done exponential and logarithmic equations, the inequalities are pretty simple. So, we're going to start with this one. We're going to solve 3 to the x less than 20. And we're going to solve this the same way that we solved the equation. It's just it has an inequality there instead of an equal. So first we write our original inequality. And then to get rid of this 3, so we have the exponent by itself, we are going to take the log base 3 of both sides. And if the logarithm has the same base as the exponent, those bases cancel out, just leaving you with x less than log base 3 of 20. Now, if you'll notice, all this does is write the original exponential inequality as a logarithmic form. However, if you're going to do that and just bypass this second step here, you have to be very careful that the inequality stays in the same orientation in relation to the variable. So since this was x less than, it needs to still be x less than. So that's very important if you're going to try and bypass this, which is fine. You can do that. Just make sure you're very careful about that. So our answer is x is less than log base 3 of 20. We need to know what that number is so we can use our calculator for this. And log base 3 of 20 is approximately 2.727. So our solution is approximately x less than 2.727. So not too bad. And let's take a look at another one. This one is in logarithmic form instead of exponential form. So here we have a logarithmic inequality, logarithm of x, common log, notice because there's no base. So common log of x is less than or equal to 2. So we're going to, 2 ways we can do this. One, we can take the algebraic approach to this. Common log of x less than or equal to 2. We want to get rid of this logarithm. Logarithm is base 10 because it's common log. There's nothing there, so it's a 10. So we're going to have this as 10 to the common log of 10 to the common log of x less than or equal to 10 squared. Base of the exponent, base of the logarithm are the same, so they cancel out and they go away, just leaving us with x is less than 100, 10 squared. And again, we could just bypass this and come straight down here to x less than or equal to 10 squared, writing it in exponential form. And again, be very, very careful if you do that, that the inequality stays in the same orientation related to the variable. So since this was x less than or equal to, it needs to stay x less than or equal to. Now, if we had some other arguments in there that was changing things, then that might change this. But we don't. So it's just x less than or equal to because it was less than or equal to up here. All right. So we have that, x less than or equal to 100. Easy, done, right? Not quite, because it's logarithms. Logarithms have this extra little problem to them, and that's that the argument to the logarithm cannot be negative or 0. It has to be greater than 0. So, since this only works when x is greater than 0, we need to say that x is going to be greater than 0. So x has to be greater than 0, but less than 100. So 0 less than x, less than or equal to 100. Notice this one is always going to be less than. This one could be equal to depending on the original problem. So since this one's equal to, x is less than or equal to 100. But the 0, it's always going to be less than x, not less than or equal to x. Okay. Now we could also do this graphically, which is much, much easier. So graphically, we take whatever's on the left, common log of x, that goes in as a y1. Whatever's on the right, 2 goes in as y2, and we graph them. Use the intersection feature of your calculator to find where they intersect, and we see they intersect right here at x equals 100. Probably going to have to change your window to do that. All right, so x equals 100, y equals 2. We're just interested in the x values. All we have here is x values. So what we need to look at now is where does the logarithm function, this red line, below, because less than, 2. And we see that happens to the left over here. So those are the less than values, smaller x values. So we want x to be smaller than 100. And you'll notice the graph stops at the y-axis because we have that vertical asymptote right there. It's going to get close to the y-axis, but it's never going to touch x equals 0. So we need to say that we're not going to touch x equals 0. So 0 less than x less than equal to 100. All of this is good, but we don't want it over here where it's greater than the other one. All right, so there is exponential and logarithmic inequalities. Not too bad. What I want you to do is work out these 4 here. You can do them graphically or algebraically, either one. I want you to pause the video, work these out, and then come back and check your solutions. All right, so you're back. Let's see how you did. 9, 10, 11, and 12. Looks like this. If this is what you got for your answers, congratulations, you got this. Well done. If not, let's work it out. Let's see what's going on here. So number 9, we have e to the x less than 2. So I'm going to write this in logarithmic form. So that would be x less than the natural log of 2, because remember, base e is natural log. So I can just type that in my calculator, and there it is, x less than approximately 0.693. All right. Number 10, original problem. This one's a little bit more complicated because we have this extra stuff going on here, but it's not too bad. We're going to write this in logarithmic form. So again, the inequality stays in the same orientation relative to the x. So we have 2x minus 6, that's our answer now, greater than log base 10 of 3, so common log of 3. You need to get x by itself, and I'm going to go ahead and solve this, put that in a calculator. It's approximately 0.477. Add 6 to both sides, divide by 2, and there it is, x greater than 3.239. Right there. All right, number 11. Original problem. Subtract 9 from both sides. Now we have the logarithm all by itself. We're going to put this in exponential form. So x, this is x less than 10, because it's common log, so it's base 10. 10 to the 36th. And we're not going to work that out, because 10 to the 36 is 1 followed by 36 zeros. And I probably don't have room for that on my screen. Let me just leave it like that. All right. Now, however, since this is a logarithm, x cannot be negative. And so we need to say that it's going to be greater than 0. So 0 is less than x is less than 10 to the 36th. All right. Number 12. Original problem. We're going to get this logarithm by itself, so we have to move the 1 over, so we add 1 to both sides, divide by 2, and so natural log of x is greater than 2.5. We write this in exponential form. X is greater than e to the 2/5 power. Put that in the calculator, and we end up with x is greater than 12.182, approximately. Now, on this one, it's a logarithm, but we didn't have to mess with this 0. And the reason for that is because this is saying x is greater than 12. And if it's greater than 12, it's never going to go negative. So we don't have to worry about that in this case. All right. And I think that is, yeah. All right. So there it is. All right. Hopefully that helped. That is basically it. You just take it, isolate the exponential portion, write it as a logarithm, or isolate the logarithmic portion and write it as an exponent. Make sure that the inequality stays facing the x, whichever way it was to start with. Alright, so don't flip it around, which makes it a little bit weird writing, because we generally put the logarithm side on this side over there, and we generally put this over here and the x over there. But if you do it that way, that's fine. Just flip your inequalities around with your x. So, no big deal. Hopefully this was helpful, and I'll catch you next time.